in week 2, we're looking at situations which we'd like to model by setting up functions. In particular, in our first mini lecture, we had an example where we had set up an equation involving costs. Related to understanding equations for costs are also equations involving revenue, involving profit, and involving the break-even. So this lecture is basically a verbal lecture on setting up different formulas. As you can see, the very first formulas, we repeat what we learned about cost. In this one, our cost function will be fixed costs plus variable costs. And we can sometimes represent that as FC plus VC. And if instead you like to have that with a few more words in it, it says fixed costs plus variable cost per unit times number of units produced. And then you could write it using the shorthand with some letters. A related equation is the equation involving how much money you obtain when you sell the products that you produce. That's the revenue equation, and that's selling price per unit times number of units sold. And in terms of a shortened form with just letters, that's P times X. Of course, this particular revenue equation and the cost equation do assume that you're looking at just one product at a time. Finally, if you want to deal with finding profit, profit is revenue minus cost. So if you wanted to construct the equation, you'd take the equation for revenue and subtract from it the equation involving cost. Now, using these things, we can actually determine a break-even point for producing a product. And this is the point at which your product stops costing you money to produce and sell, and where you actually start to generate a profit for your company. This is one of the first powerful tools that decision makers learn how to use. It does look at relationships between variable costs, fixed costs, and revenues related to your sales volume. And it is one tool that the manager can use in order to make decisions. So some problems that this might help you use is it might help you to decide on what price level you should charge, what's the optimal variable fixed cost combinations, and whether this is an attractive option for your company. There are some particular assumptions that you're making when you're doing this particular analysis, and of course these aren't always true, but it helps us to understand what these assumptions are. First, that there's only a single product involved. Second, everything that is made is sold. Third, both per unit production cost and selling price per unit are constant regardless of the volume. And fourth, all costs are known and fixed. Now, when you want to continue further and actually calculate the break-even point for your equation, you do see that the break-even point is when profit is 0 and total revenue equals total costs. So that's how you would set up your equation when you want to try to calculate that. To conclude our study of this section, what we're going to do is we're going to look at one complete example in a series of stages where we'll use the different concepts that are involved in break-even problems. This will give you some good examples of modeling mathematical behavior related to business by using these equations. So the assumption is the following when we're starting off this example. is that we have a company called the Puritron Company, which manufactures water filters. The monthly fixed cost is $20,000, and the production cost or variable cost is $20 per unit. The company sells each water filter for $30 per unit. So the first question says, find Puritron's cost function, and we're going to let the variable x denote the number of units produced. So as we learned before, total cost is fixed costs plus variable costs. Now to express that, the fixed cost from the paragraph above are $20,000 and the variable costs are $20 times x. That's the number of units that you're producing. The second question is, what is the cost of making 500 water filters? So what you do there is you take the cost equation that you just generated and you substitute for x the 500 water filters. So calculating that out, you'll have 20,000 plus 20 times 500, which will give you 30,000. Another alternative is, suppose you know the cost, but you don't know exactly how many filters you produced. So what you can do is you can replace the cost by 45,000 and then have 20,000 plus 20x, solve that particular equation as you normally solve a linear equation, and you get 1,250 units for x. Next, what we'd like to do is we'd like to find the revenue function or revenue equation. So we said in our first paragraph that the selling price was $30 per unit sold, so the revenue equation will be 30x. Number 5 says, what is your revenue when you sell 5,000 filters? So you take the revenue equation that we just found, substitute 5,000 in for x, so we'll get 30 times 5,000, and when we multiply that out, we'll get $150,000. Number 6 says, find Puritron's profit function. So profit is going to be the revenue function minus the cost function. So that's 30x minus, and then you have parentheses here, 20,000 plus 20x. When you simplify that, you get 10x minus 20,000 for the profit function. Number 7 says, what is the profit in producing and selling 5,000 filters? So you use your profit function, substitute 5,000 for x, and when you do that and calculate through there, you get 30,000 for an answer. Then, to complete this problem, we want to know, what is the break-even point? So how much do you have to produce and sell before you actually start making some money? So it's the profit function, 10x minus 20,000. You want to set that equal to 0 and solve for x. When you do that, you move 20,000 to the right-hand side and divide by 10, and you get the break-even point is 2,000 units.